This is Euclid Book 7, proposition number 22. It says, the least numbers of those which have the same ratio with them are prime to one another. Let A and B be the least numbers of those which have the same ratio with them. I say that A and B are prime to one another. Okay, let's say the numbers are 12, 11. Okay, those are numbers that are prime to one another. Okay, they're not, both of them aren't prime numbers, but they are definitely prime to one another. It just so happens that 11 happens to be a prime number. Okay. Let some number measure them and let it be C. Now we're going to presume that A and B are 12 and 8. I'm going to show you this diagram right here. Okay. Alright, so if A and B are 12 and 8, for if they are not prime to one another, which 12 and 8 are not prime to one another, some number will measure them. Let that number be C. Well, C measures 8, and C measures 12. Okay? And C in this case is 4. And as many times as C measures A, so many units let there be in D. Okay? So, C measures A twice. I'm sorry, C measures A 3 times. C measures A 3 times, so D is 3. Okay? And as many times as C measures B, so many units let there be in E. Well, C measures B twice, because 4 measures 8 twice. So E is now 2. Since C measures A according to the units in D, therefore C, by multiplying D, has made A. And this is by Euclid Book 7, definition number 15. Well, 4 times 3 equals 12. For the same reason also, C, by multiplying E, has made B. Well, 4 times 2 makes 8. Thus the number C, by multiplying the two numbers D and E, has made A and B. Therefore, as D is to E, so is A to B. So as 3 is to 2, so as 12 is to 8. And that's true, and that's by Euclid Book 7, proposition number 17. Therefore, D and E are in the same ratio with A and B, being less than they, which is of course impossible. Now, what that means is that if you're using the numbers 12 and 11 instead of 12 and 8, all of this becomes impossible. And you can check your computations for yourself. Because number one, C would not be able to measure both A and B due to the fact that A was 12 and B was 11. Okay? And then even if it could, you'd have two numbers that were less than A and B, but being in the same ratio as A and B, and we said in the beginning that they were not. Therefore, no number will measure the numbers A and B. Therefore, A and B are prime to one another. And there's your proof. I will tell you more in a future video. Stay tuned.